In this video, we'll be talking about the properties of logarithms and then using those properties to rewrite our logarithm. The first property is the log of a product is equal to the sum of the logs. Now, if you can remember that a logarithm is an exponent, it may help you remember, for example, if we have x squared times x cubed, we add these exponents. So this would be x to the 2 plus 3. So the log of a product is equal to the sum of the individual logarithms of the factors. The second property is the log of a quotient is equal to the difference of the logs. And again, if you can remember x to the third divided by x squared, the rule for performing this operation is to subtract those exponents. Our third property, if we have an exponent on our argument, then we can take that exponent out in front of the logarithm and write it as the exponent times the log. Our fourth property is if we have an argument of 1, then the logarithm is equal to 0. And this comes from the fact that a raised to the 0 power is equal to 1. And then our fifth property is if the base and the argument are the same number, then the logarithm is equal to 1. And this comes from a raised to the 1 power is equal to a. All right, now on our examples, we're asked to rewrite each expression by expansion. So when we have factors of the argument shown, we can use property 1 and rewrite this as the sum of the logs of the individual factors. So we can write this as the log of 8 base 7 plus the log of 6 base 7. Our next one, we have a quotient. So we could use property 2 when we have the argument that's a division. We can write it as the difference of the logs. So this would be log of 12 base 6 minus the log of 5 base 6. Our next one, we would need to rewrite this as an exponent, and then we can use the third property. So as an exponent, this is 9 raised to the 1/3 power, because my exponent on the 9 is a 1. Now when I apply this third property, I can bring that out in front. So this is the same then as 1/3 times the log of 9 base 2. Now in this one, I have a number of factors multiplied together in the numerator and a number of factors multiplied together in the denominator. So I'll be using properties 1 and 2 for this one. I'll do it in 2 steps. I can write the factors individually, the log of r, and all of these have a base of b on the logarithm. So the log of r plus the log of s squared, base b, plus the log of t with base b. And then, since these are in the denominator, I'll need to use property 2, so subtract the log of u cubed with the base b, and subtract the log of v to the 5th with the base b. Then I can use my third property to bring these exponents out in front of each of the individual logs. So I'll do that for each of those that have an exponent on the argument. And so my final answer on this one is the log of r base b plus 2 times the log of s base b plus the log of t base b minus 3 times the log of u base b minus 5 times the log of v base b. Our next example, we'll need to write this as an exponent first, this radical. So let's rewrite that log, and we have a base of a. The r is raised to the 3 over 5 power. Now I can use my third property that says I can bring that exponent out in front of my logarithm. So this would be 3/5 times the log of r base a. And then my last example, I'm going to write this with an exponent. So this is the log, and I have 1 over m power, and then my argument, or my radicand, is r to the 3rd s squared and t to the 4th. And the base is a. Now you can do this in a couple of different ways. I'm going to go ahead and bring this exponent out in front first. Since I have quite a few factors here in the argument, I'll need to use parentheses on this. So I can say that this is 1 over m times the log base a of r cubed plus the log base a of s squared. And then since this factor is down in the denominator, I'll have to use property 2 on that one. So subtract the log of t to the 4th power base a. Alright, now I'm going to use the third property and take these exponents in front of each of the logarithms. So this is 1 over m times 3 log r base a plus 2 log s base a minus 4 log t base a. And finally, let's distribute our 1 over m. And I have 3 over m log r base a plus 2 over m log s base a minus 4 over m log t base a.